All right, this is week 8. There's 2 experiments. We have belly up and telegraph lines. So for, it's actually, we're gonna do number 56 first, which is belly up. And we'll sing the scientific method. And then our question or purpose is, have you ever had a pet fish die, or have you ever seen a fish floating in a dead fish floating in the lake? So asking the kids, how does that dead body float? And then the answer is it's belly side up on the surface. And so today we're gonna learn about why dead fish float upside down, and we're gonna add some water to a bag to learn how fish float. Some of the questions we might have are, why do dead fish float? And why are they upside down? And how does a little bit of air in a water bag resemble a dead fish? So our research or our background information is, what are some things you already know about fish? Well, we know that fish can be classified. We can sing the What Are the Classifications of Living Things song, the domain, kingdom, phylum, class, and order, family, genus, species. What kingdom are they a part of? Again, we can sing What Are the Kingdoms of Living Things? Animalia, Plantae, Fungi, Protista, Archaea, Bacteria. They're part of the Animalia kingdom. They have spinal cords, so they're vertebrates, and they reproduce with eggs. So we have all these science sentences. So we can sing, what are some ways that animals reproduce? Live birth, eggs, fragmentation, and budding. And then we're going to talk about what kind of items sink and what kind of items float. So the kind of items that sink are a rock, a penny, a nail, things like that. You can let the kids name off some things. What are some things that float? A ball, a straw, goggles. And then for our hypothesis, or taking a guess, ask them, what do you think will happen when this bag that's going to be filled with water, what do you think happens when we just put it filled with water in the bowl of water? We're going to have a big bowl of water, which you'll need to bring the bowl from home, and then you'll fill it up at CC. And then you'll put some water in your bag too and seal it up. But you're going to say, what do you think will happen when this bag of water is given a little bit of air? Do you think it'll sink or float? What's your hypothesis? And then for the experiment, our materials and procedures, what materials are we using for this? Just let the kids look. It's basically just a bowl, water, your little bag, and a straw. And so we're going to fill this bag up part way with water, and we're going to get all the air out of it and seal it. And then we're going to place it in the bowl of water, and we're going to ask the kids, what is it doing? And it should be floating under the surface of the water. Now we're going to just bring the zip part up, leave the rest of it kind of in the water, and bring the zip part up to the surface. And we're going to open the bag a little bit and place our straw in, and then zip it up all the way around the straw. And then we're going to just blow into the straw so that we get some air in there, and then quick seal it up. Make sure that it's sealed all the way. And then we're going to look and see what happens. And so our analysis, or noting our results, is what happens. And it should float on top of the water with kind of with the air side up. So our conclusion, our figuring it out, is why did this bag float on top of the water when there was air in it? So the answer is, well, when an object will float if it is less dense than the water, and it will sink if it's more dense than the water. So a fish is only a little tiny bit more dense than water. So if it is more dense than water, even by a little bit, shouldn't it sink? Well, here's something that's interesting. So inside the fish, and we have this image here that shows the fish's swim bladder. There's something called a bladder, and the way it's located near the belly, and when the fish is alive, that bladder helps the fish keep just the right amount of air in it. But when the fish dies, there's oxygen that's trapped in there, and then when food gets in there and it kind of, with the chemical decomposition and everything, it produces gases, which makes it have more air is created. And so then it becomes the gas is less dense in that water, so it ends up floating, and it's upside down because of where that swim bladder is located in the fish. So for that one, it's going to not be a hands-on one for the kids. They're just going to be watching you. So you, from your tutor bin, make sure that you get your little bag and your zip thing, and it's in a little container like this. And then bring a larger bowl from home and fill it up with water when we get there. And then our second experiment is called telegraph lines. And what you're gonna need, you should have some tape already in your tutor bin, so just make sure you do. And then also in this little baggie, you have some fun string. So take that out, and then you should have some scissors in your tutor bin, so just make sure that you grab your tape and your scissors when you go to science. So again, you're gonna start out, well, you can sing the scientific method again. And then our question or our purpose is, how does a spider sense that something has landed on its web, and how does it know if it's dinner or danger? How can it tell the size of the intruder? And just explaining that an intruder is something or someone that comes uninvited. So today we're gonna pluck a tight string and use our sense of touch to feel different vibrations. So our research or our background information is, what do you already know about spiders? We can say that they have 8 legs, they're part of the animal kingdom, they reproduce with eggs. And then ask the kids what their 5 senses are. So height, sight, hearing, taste, smell, and touch. What do we still need to find out? We need to find out how spiders sense the world around them, what senses that they use and to protect themselves, and also to eat. Our hypothesis, or our taking a guess, so we're gonna say to the kids, do you think that we can sense or feel a difference when we pluck a string using a gentle or a firm pluck? Do you think that we can feel if the pluck is close to us or far away? And how do you think a spider knows the size of its intruder? So for our experiment, our materials, again, we'll just say to them, what are our materials? And our materials are gonna be string, tape, our fingers, and tables or chairs. So what we're gonna do is we're gonna take the string and you're gonna secure it between 2 stationary objects. So that could be 2 tables if you have them, or 2 chairs. If you do 2 chairs, you're gonna want kids to sit in them so that you have weight and that the string can stay tight across. And then you're gonna ask for an assistant, or it could be a parent. It kind of depends on how your class works. And you'll just say to the kids, I'm gonna put my fingers on this string gently, like how I would touch a butterfly. So just really gently on top of the string once it's already pulled across. Like, you're gonna take that string and tape it to a couple stationary things, and then I'm gonna put my fingers really gently on one end of the string, and I'm gonna look away while my assistant tries plucking the string, and then they're gonna do it a little bit firmer, and I'm gonna try to feel if I can tell a difference. And so I asked the kids, in this experiment, what role am I? I'm the spider. And what role is the assistant? And it could be, the assistant would be the intruder, like maybe a fly or a bee or a frog. So you can try this by having the spider and the intruder move to different places on the string, always with the spider looking away. And you can let the kids take turns doing the roles too, if they can handle it, so they can kind of feel the vibration too. So then our analysis, our noting our results, is what did we observe about the vibrations? Well, both weak and strong vibrations can be felt from all parts of the string. But when it was a gentle or a small animal, such as a fly or a bee, the vibration was less. So you could even say to the kids when they're doing it, be a frog, be a butterfly, be a spider, and so that would determine how strong those plucks were. When it was a large intruder, like a frog, it was stronger. So our conclusion, our figuring it out, is most spiders, even though they have many eyes, so going back to those senses, they have lots of eyes, they don't actually see very well. So the way that they stay safe and eat is by paying attention to the vibrations on their webs. They feel the vibrations mainly through the hairs on their 8 legs. And most of us will have pants on. So we're gonna use our arms and we're gonna just have the kids pull up their sleeve and just kind of lightly rub the hair on their arm and ask them if they can feel it. And yes, and spiders have to be able to tell the difference between a juicy fly, yum, to eat, and a dangerous predator that's out to eat them. Spiders tune their webs for just the right tension and stiffness to be able to sense the right vibration. So just even talking about how God created us, or even the animals, so uniquely that they can have those senses of, you know, the difference between a bee and, you know, something else that's small too. And just that's how that God made it so that they can eat that way and protect themselves. So that, just saying again, that large vibration means danger, so spiders won't come out, or you know, they'll even cut away their attachment to their web for protection. While a small vibration might just be the wind and the spider would ignore it, but the spider learns and knows how to read those different vibrations. But the right vibration will send a spider dashing out to dine. Its legs will spin and wrap up that trapped food with silky strands that come right out of the spider's own body. And then the spider will actually poke the prey, poke the animal with a poison that makes its insides turn to liquid, and it sucks out the juices. So the boys will especially love that, and the girls will all say, ew. And if there's any extra time that you can, you know, again, you can have the children act out what they would do if they felt a gentle vibration or a strong vibration or just the right vibration. There is, I think I would just show this at some point in time, just the picture of the spider's web, and there's not necessarily much to refer to on that, but